So my name is Diniti Gunavardhana. So I'll be presenting about my project now. So my project title is A Robust Approach to Automatic Speaker Verification with Deep Learning and Explainable AI. So this is the agenda throughout this presentation. So I want to cover these points like problem definition, the research gap of my project, proof of concept, and all these mentioned points. So without further ado, I will start. So this is the problem definition of the project. So when I started my final year project, when I was looking for a topic, I wanted to do deepfake detection. But then I started like reading all these research papers about deepfake detection, and it was after like going through some papers only I got to know that audio deepfake detection has like a significant gap in research, because this specific area is not that research like image deepfake detection. When it comes to deepfake detection, what everyone does is researching on image deepfakes and not audio specifically. So I thought of choosing this area because of that, because there's a gap exists in this area. So as in when it comes to audio deepfake detection also, like there are so many areas, but I chose automatic speaker verification systems specifically. Automatic speaker verification systems are mainly like speaker verification systems used in like bank applications or smart home devices. So when it comes to a smart home device, what they do is they recognize the voice of the owner and then they unlock the door, then they turn on a TV, stuff like that. When it comes to banking, they give speaker verification for bank account to transfer money, stuff like that. But these kind of applications are vulnerable to audio deepfake because anyone can, like hackers can imitate the owner's voice and get through a system like this. So also because of this I chose automatic speaker verification systems, and also I wanted to like look up on XAI, explainable AI, because I wanted to give like a transparent result from this system I want to make. So because of the black box nature of current existing system, they don't give how the output is coming, they are not as transparent. So I want to touch upon this subject as well throughout my project. So I'll be looking on automatic speaker verification systems with explainable AI and deep learning. So I did a lot of research on this, like I read a lot of papers. So these are like the points I actually found that significant. So like when it comes to audio deepfake detection, there are actually systems currently also, but most of the time these systems only focuses on detecting like fully fake audios. Like all the systems are detecting fully fake audios. Most of the time all these like research papers focus on detecting fully fake audios. So partially fake audio seems a challenge. There are some research done on this as well, like waveform boundary detection and ADD challenge, but these are all in Chinese language, not English. So this has a pretty much of a gap when it comes to English language. So while going through these literature, audio deepfakes have three main types called imitation based, synthetic based, and replay based. So imitation based is when like a person's voice is imitated through a deepfake. Synthetic based is basically text to speech, like they use text and generate speech from it. And replay based is you are like recording someone else's voice and replaying it to someone else while like taking their identification. So it is also a kind of a deepfake. So just like fingerprints to people, like fingerprints are unique from each person, just like that audio, like our voice is also unique from person to person. This is mostly get like when it comes to voices, we can measure that from several voice features like male frequency cepstral coefficients. These are called MFCCs, and there are LFCCs, CQCCs, like constant Q cepstral coefficient. There are unique features for each voices, and these can be measured by these features. So most of the time when it comes to audio deepfake detection, these features are analyzed. So I will touch upon that later. And other literature findings I came across are like explainable AI. Most of the time explainable AI not that used in current research. And hybrid models showed a more like good accuracy than like single model approaches. So this is my research gap. based on research on deepfake detection, most studies primarily focus on monomodal approaches like image detection being most prominent. While existing detection methods have made progress in detecting fully fake audio deepfake, detecting partially spoofed audio, as in partially fake audio, remains a challenge. So because of this, there's a gap in detecting partially fake audio. So this is my main research gap. So these type of manipulation is most vulnerable to automatic speaker verification systems, because anyone can use an owner's voice and get into their systems very easily, and it is a threat to their privacy and threat to everything. So this is what I want to address during my research, and this is my research gap. I will show you my concept gap. So this is my concept map. So I actually like went through literature and made this. So there are like when it comes to audio deepfakes, they impact audio-based scams, social implications, ethical concerns. These are the types, challenges. So yeah, this link is here if anyone wants to access it. And then this is my project aim. So I want to design and develop a robust approach for detecting partially spoofed audio in automatic speaker verification systems, and also address this gap by, I want to address this by incorporating explainable AI, so it enhances the transparency of my system. So yeah, this is my project aim. And when it comes to my pipeline, I will be using public data sets like ASV spoof or maybe Wavefake to collect data, and then I'll pre-process them, then feature engineer them, as in like mostly I will focus on MFCCs or CQCCs, just like I previously mentioned. There are unique features for every voice, so I'll be focusing on them. And then for the model selection, I don't want to like focus on a single approach, so I'll be going to a hybrid approach, and then I'll train it and deploy it. So this is just like my basic pipeline of the project. And when it comes to the requirement elicitation methodologies for my PPRS, I did interviews with 2 domain experts, and they both told me to focus on explainable AI, because explainable AI is actually not touched upon on most systems. So document analysis is my main requirement elicitation methodology, because I did most of this research through reviewing literature, and I also brainstormed during sessions with my peers who are like doing some similar research like me. So these are my SRS findings. Through my software requirement specification, I identified the key stakeholders of my system, like the user, and I thought of maybe like an operator can be in the middle and operate the system. So yeah, just like that, I identified the stakeholders. And then through document analysis, since I focused on reviewing documents, I found out that training-free approaches like which don't require like extensive training have improved detection performance recently, and also leveraging pre-trained models. So when it comes to audio defect detection, there's a challenge called ASV spoof, which started back in 2015. So this is like a main challenge in audio defect detection. This is like the only, like the first ever challenge based on audio defects. So afterwards there are other challenges also, like ADD and other challenges. So ASV spoof's challenge dataset has so many like audio defects in their datasets, and they have several datasets for each focusing on other like several areas of deepfakes. So because of this, so like throughout the years there are so many pre-trained models also developed for audio deepfake detection, just like Hubert. There are this model called hidden unit BERT, it is called Hubert, and there are this other model called Vow to Wake, and there are RONet 2 models, such as there are so many pre-trained models. So through my document analysis, I found out that pre-trained models help to transfer knowledge across different data sets, and using them is also very advantageous. Also, like hybrid approaches has more accuracy than just like traditional machine learning approaches. So yeah, that's what I found through my document analysis. And then when it comes to functional and non-functional requirements of my project, I used Moscow technique. So functional requirements, when it comes to like my functional requirements, must ones are like there should be a feature to upload the audio. It is a must, it is like the main thing. And then since I'm focusing on partially fake segment detection, there should be a feature for that also. And then the result should be displayed with explainability, because I'm focusing on the explainability as well. And also robustness metric evaluation is the should. Also additional insight from detection output, it can be done after model deployment. And non-functional requirements are file size limits. So I want to have a limit of file, like I want to put like a range of file sizes for users, so I will be focusing on that as well. And I want to have a user-friendly interface and accurate detection output process explanation capability. Those are my other non-functional requirements. And yeah, so proof of concept, this is like the main part of my project. So what I used was, I used this data set called LJ speech. So it's a speech data set with a single speaker's voice, like all the data of that data set was from a single person. And this wave fake data set is like a combination of other data sets, and it has this fake data obtained from the LJ speech data set. So basically I used LJ speech for real data and fake for their fake data. So I use these two, and then I built a CNN layer using Keras, and then I extracted MFCC, just like I told before. MFCCs are like a good audio feature, so I extracted that. And then my model has this accuracy 86.51%, which is pretty good. So I'll show you my notebook now. So this is my notebook. I actually copied it from a Kaggle user, but that code didn't work. Like the model was not well trained or not even working, so I had to do so many modifications by myself. I tried to visualize data, like I'll show you. So this is real audio data. So this is like a waveform, like audio data, how it is visualized. This is a spectrogram of it, and this is a male spectrogram. MFCCs are in this. So you can see how the MFCCs of that actual video data is visualized here. And if you see, like this is the fake waveform and this is the real waveform, they don't actually have that much of a difference because they sound basically the same. But MFCs, so this is the real MFCC visualization and this is the fake one. It has a bit of a difference if you look at this, but we can't look it through our own eyes, so we have to do a model deployment in this. So I used Keras and then extracted features and trained. This is my model architecture. And so yeah, I had 100 epochs, so I iterated 100 times and did this. So this is my accuracy, precision, recall, all the other evaluation metrics I got. And this is my accuracy curve for validation. This is the training and validation loss. So yeah, I will show you. So this is the real and fake waveforms. They basically look the same and they sound the same. So this is the spectrogram. This is the male spectrogram. This is the chromogram, and then MFCCs. See, they quite basically look the same. They don't look like, they look the same if you look at this. So yeah, then I did my CNN layer and trained the model. So yeah, then challenges and contributions. When it comes to challenges, what I had, like my key challenge was finding a proper data set for partially spoofed audio, partially fake audio. I could find it because most of the data sets are like on fully fake audio. So there are some data sets like ASV spoof, it is there, but most English data sets are very rare to find, and most of the partially fake data sets are in Chinese language. And the other challenge is integrating XAI, so I will be working on this. And when it comes to the contribution of my study, I will be making a novel method to detect partially spoofed audio and ASV systems, and I will enhance the transparency through XAI. Also, in conclusion, this project aims to contribute to enhanced security in automatic speaker verification systems by presenting a novel approach to partially fake audio detection. And my POC, even though it's a basic code, it shows good results. So I will be modifying it for my final results, and I will focus on transfer learning approaches and other hybrid approach to modify my models. So yeah. That's the end of my video. Thank you for listening.